Good morning, children. I am your Kiran sir. After a long time, we are meeting through these online classes. I am very happy to interact with you all in this week. I hope everybody are safe at home by the grace of God. Now, you all completed 7th class and step into 8th class. In 8th class, the first chapter in physical science is force. Before going to know about force, we will discuss some basics informations, that is physical quantities. What is mean by physical quantities? To understand what is mean by physical quantities, we will consider some examples. Suppose if you observe a TV in your home, I will ask a question to you. What is the size of that image? So you can express in your hands this much, sir, this much, sir, like that. Okay, if I ask another person, in your home also TV is there? So that is also this much of size only? No, no, sir. In my home, it will be somewhat bigger. Sir, other person if you ask, he will also say, sir, in my home it is still bigger, sir. So that means here all the objects TV is having a one characteristic. That is the sizes are different. To express this characteristic size in the physics, we are using a quantity, name it as length. Name it as length. Similarly, one more example if we consider, suppose if you take any two mangoes, maybe one mango is big in size, another mango is small in size. Okay, some other, a full bag of mangoes are filled with mangoes only. Okay, suppose if I keep one mango in your hand, you will feel somewhat painful. Suppose two mangoes, if I keep in your hand, you will feel somewhat more pain on your shoulder. Suppose if I keep a bag of mangoes on your hand, you will feel so much pain and you will say, sir, it is paining, sir. If I ask a question why it is paining, you will say, sir, the weight of the bag is more than the weight of the mangoes. So here also one more characteristics we are saying, that is weight. In the physics we are using the word is mass for our weight. So like that, every object in the universe having some characteristics. So to express the characteristics, we are we are using the word is quantity. Suppose if that characteristics are measurable and can be expressed in the form of laws, then that quantities we will call it as physical quantities. What is meant by physical quantities? A quantities which can be measured and expressed in the form of laws is called physical quantities. Example, length, mass, time, force, density, etc. etc. Some physical quantities are there which cannot be measurable. Okay, the physical quantities which cannot be measured are called as non-physical quantities. Example, love, kindness, depression. Can you measure the love? No, it is not possible. Can you measure how much kindness do you have? No, it is also not possible. That's why these all characteristics of you, love, kindness, depression, these all are not come under physical quantities. The physical quantity can be represented by using two things. They are magnitude and unit. Example, if I ask a question, what is the length of your classroom wall? So you can say the answer like this, and it is a 5 meters, otherwise 6 meters, otherwise 10 meters, so on, so on. Let us consider it is a 5 meters. Suppose if I ask a question like this, what is the meaning of 5 meters? Then you will say, sir, suppose the stick length of this stick is 1 meter, the length of this wall is 5 times of this 1 meter stick. That means here the 1 meter we are considering as standard unit, and the 5 times we are calling as magnitude. So physical quantity can be expressed in the form of like this. Physical quantity is equal to magnitude into unit. Is it clear, children? Now we will understand. So we gave the example. Force is also one of the physical quantity. So our concept name is what? Force. Now you already understand something about force. What is that? Force is a physical quantity. So detailedly we will discuss about the force. What is meant by force? So to understand the concept of force, first we will observe what are the changes are taking place around us. If we observe what are the changes are taking place around us, we can see so many changes like this. What are the changes? Changes in seasons, changes during sunrise and sunset, changes in tides, etc., etc., etc. These all changes, what you are observing around us, do you get any doubt anytime? Why these all changes are taking place? For example, for example, I will ask one question to you. I will ask one question to you. A ball is there in front of you. Without without kicking the ball, okay, now if we say a ball move somewhat forward, the ball will move. No. Suppose if I say, my name is Kiran, I am saying to you, a ball, move from here. The ball will move? No. Hey, my name is Kiran, sir. The ball, move. Ball will move? No. When the ball will move? When you kick. That means when you push. Otherwise, when you pull. Is it clear? That means when you apply a push or pull, then only the action. What is that action? Moving of ball will takes place. Otherwise, the ball is in previous state. What is the state? Rest or are in uniform motion. So similar way, so many actions in our day-to-day life also we will observe. For example, stretching a rubber band, pulling a rickshaw, or squeezing a sponge, etc., etc., etc. All this also, stretching a rubber band means what you are doing? You are pushing. And pulling a rickshaw, what you are doing? Pulling. You are pulling towards you. Okay, now squeezing a sponge, what you are doing? You are pressing, means you are pushing the sponge. So in all these cases, to change their shape or to change their state, you are applying something. What is that? We are calling as pull or push. For that, we are using a name in our physics is force. So force is simply nothing but force is simply nothing but what is mean by force? Force is an effort in form of pull or push or both, which changes or tends to change the state of rest or uniform motion. Once again I am saying force is what? Force is a pull or push or sometimes both, which changes or tends to change the state of a object. Unless until without any applying of force we can't able to change the state of an object. Is it clear now what is force means? So once again simply we can say force is a push or pull. What is meant by push? Whenever you will apply the push, at the time the body will move away from your body. What is meant by pull? Suppose whenever you will apply the pull action on any object, the object will come towards you. So that is push and pull. Is it clear? Okay, now whenever you will apply the both actions at the time, object will go somewhat forward, means move away from you when we apply push, At the same time, it will come towards you when you apply the pull action. This is the both. Where you will see this type of both push and pull. Can you give an example for that? Playing a guitar. Playing a guitar. Or once again, erasing the blackboard. At the time, what you are doing? You are pushing your hand one side. The same time, you are pulling once again back. So here you are to do this action. You are performing both push and pull. So we will discuss some more points regarding the force. What is the some more points? Force is a physical quantity. So physical quantity. So the force is a physical quantity. Okay now. Force is having both magnitude as well as direction. That's why I am calling as force is a vector quantity. Now we will get a doubt. Sir, what is mean by vector quantity, sir? What is mean by vector quantity, sir? So to understand that, I will explain a simple example. What is that simple example? For example, if I ask a question, how far your house is from the school? You will give an answer like this, sir, approximately half kilometer, sir. Suppose from our school gate half kilometer if I walk, what will come? Generally, DMart will come. So DMart is your house? No. So then what is the mistake? Then you will say, no, 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 sir. You should not go in this direction, sir. You have to go in this direction half kilometer. Then only my house will come. That means your answer is not sufficient. What is the missing in your answer? You said only the value, but you forgot to say the direction. So to express some quantities, okay, now two things are required. What are the two things? Magnitude as well as direction. Magnitude as well as direction. Suppose you already completed a task. You already completed a task. For example, you went to Uppal and you came back to your home. If I ask you a question, how much distance you traveled, then you can say, sir, from my home to Uppal 4 kilometers. From Uppal to my home, once again 4 kilometers. So total 8 kilometers I traveled, sir. For that, there is no need to express any direction. So in the previous question, compulsory direction is required. In this question, direction is not required. So a physical quantities which required both magnitude as well as direction for their representation or for their expression. Such a type of physical quantities are called as vector quantities. In the same way, force is also like this only. Now, I think you all understood what is force. Just to go through the flow chart. What is force? Force is simply nothing but push or pull. Then force is a vector quantity. Force not only living things, non-living things also can apply the force. So what is mean by vector quantity also we discussed clearly. Now we will observe some examples, some daily examples of where we will show the push action. So observe some examples. What are the examples? Pressing the switch, okay, na? And launching rocket, pushing trolley, kicking a ball, knocking a nail. These all are the daily examples of push. Next, we will see some more daily examples of pull. What is the pull? Tug of war. We all know what is meant by the tug of war. So in this tug of war, we are pulling towards us. So where we are, what type of force we are applying? Pulling. Okay, next, raising a flag, opening a door, pulling a basket, or pulling any suitcase. All this come under the examples of pull. Next, we will see where some more daily examples where we will apply both pull and push. Example is what? Sawing wood, playing guitar, scrubbing the floor, okay, rowing a boat, and erasing the school board. Everything will come under the examples of both pull and push. My dear children, I think it is clear for you all what is meant by force, and some examples where we are using pull, push, and everything. Now we'll go to the next topic. What is the next topic means? I want to give a small homework like activity for you. What is that activity? I will show a picture. In this picture, you have to say you are using pull or push or both. First one, what is this? Digging a borewell. Digging a borewell. So, in this example, you are showing push, pull, or both. Okay. So, note down your answer in your mind. Afterwards, we will ask. You have to give the answer for me. The second one is sipping juice with a straw. What is this? Sipping juice with a straw. So, picture is appearing for you all. So, in this also, you are doing push, pull, or both. Just note down your answer. Third one is brushing teeth. In this, push, pull, or both. Write down your answers. Okay, all written answers. Now check your answers. First one is what? Digging a borewell. Here you are using push. Sipping juice with a straw. What you are doing? Pull. Next, brushing teeth. What you are doing? Both pull and push. So I think by these all examples and by these activities and everything, you all are clear about what is force. Now we will discuss about the types of forces. How many forces are there, sir? So in our previous class you are learning magnetic force and some other forces, different types of forces. So all the forces are classified into how many types? How many types? Sorry, how many types? Two types. Okay, forces are classified into how many types? Two types. What are they? Are contact force and non-contact force. What is mean by contact force and what is mean by non-contact force? So to express or to use the force between the two objects or between the objects, compulsory a contact has to be exist between the objects. Then such a type of force we will call it as contact force. What is meant by contact force? Force that comes into an action after the interaction between objects is called contact force. Example of contact forces: muscular force. Example: suppose you want to lift any bag from one place to another place. So, without using your muscular force, can you lift a bag from one place to another place? No, it is not possible. That's why muscular force comes under contact force. Muscular force, frictional force, normal force, tension, these all are examples of contact force. So once again I am saying, what is the contact force? Force that comes into an action after the interaction between objects is called contact force. Examples: muscular, frictional, normal, tension. Now we will discuss about non-contact force. Suppose to perform any action between the objects, there is no need of any contact between the objects. Such a type of, without contact only the action will be performed. Such a type of forces are called as non-contact force. So definition is what? Force due to without interaction between two objects is known as force at a distance, or field force. Example of non-contact force is what? Magnetic force, electrostatic force, gravitational force. Now we will discuss one by one about non-contact force. In that first one is magnetic force. You all are very familiar with the magnets in your 7th class. You know what is bar magnets, what are the different type of magnets, what are the different shapes of a magnets. So much you learned about magnets in your 7th class. Now once again we will discuss what is mean by magnetic force. Okay, now here you are seeing a Now we will discuss about magnetic force by using an activity. Here you are seeing that a needle is rubbing with a bar magnet. So in our seventh class we already learned any magnetic material rubbed with a magnet several number of times. What will happen? What that process is called as? Do you remember, children? No? Or somewhat? Okay, we will discuss once again. So we will learn this magnetic force through this activity. Take a sewing needle, rub it with a bar magnet several times. Note, whenever you are rubbing, you have to rub always in a single direction. Okay, then if we rub the sewing needle with with a magnet several number of times, the sewing needle will become a magnet. Then afterwards, with the help of a compass, identify which side of a magnetic needle is north and south. Once again, I am saying with the help of a compass, identify the north and south poles of a needle. After identifying, pin a red colored cork ball to the south pole and a white ball to the north pole of a needle. Then what you have to do? Make another needle like this only in the same way. Then afterwards take a bowl and fill with some amount of water. Place these two needles in such a way that first time or in the first case the two needles of a north poles has to face each other. Otherwise south poles are face each other. At that time what you will observe. In case 2, okay, place the magnetic needles like this. The north of a one pole faces the south of a another pole. So in these two cases, what you will experience? First case, both the poles or both the south poles are facing each other. At that time, you will experience a repulsion or push. Similarly, when opposite poles are facing each other, at the time you will experience attraction and we can call it as pull also. That means here between the two magnetic needles, a force is developing. Okay, now, but here any contact is there between the needles? No. Okay, what this force is called as? Here needles are acting as a magnets. That's why the force between these two magnets are calling as magnetic force. What is meant by magnetic force? The force exerted by any magnetic objects is called as magnetic force. The magnetic force is also called as field force. Okay, now we will discuss some questions maybe arise in our mind while I am explaining. What is that? Sir, you explained the physical quantities. At the time you said the examples are length, mass and everything. So you said force is a vector quantity. Okay, now, sir, we are getting a doubt. So in the physical quantities, length, mass, time you said, na sir, is the length, mass, time is also a vector quantity? So, what is the question I am asking? Is length a vector quantity? Just think it a while. The answer is no. Length is a scalar quantity. Why it is a scalar quantity? To represent this physical quantity length, we no need direction. That's why it is a scalar quantity. Next, one more question may arise in our mind. Sir, what is meant by magnetization, sir? So, at the time of explanation of magnetic force, I said one thing. Take a sewing needle and rub with a magnet several number of times. That process only called as a magnetization. So, what is meant by magnetization? The process of making a substance temporarily or permanently magnetic by intersection of a magnetic effects. Good morning. So, up to here we discussed today. The next non-contact force we will discuss tomorrow. So, I am giving you some homework for you. Observe the slide and note down the questions and write the answers